Given the Forbes graph as a scatter plot of velocity of growth from the 15th week of gestation to the 25th week of postnatal life, the given velocity of graph made us assume that it is the derivative, allowing us to find a line of best fit of the fetus and placenta. Also given the Forbes graph scatter plot of velocity with the XL, the line of best fit for the fetus and placenta had to be much more accurate. That would put the line of best fit as a polynomial of degree 4. So we wanted to see the difference between W and W double prime of T of the fetal weight growth. So we basically graphed the rate of weight growth of the fetus, and it's just the original function. So to get to the original function, we use the velocity derivative, which was the degree 4 polynomial. And basically on the left, you see that it goes concave down, concave up, concave down, and concave up. So those points are basically when the line shifts either up or down, increasing, decreasing. And on the graph on the right, you see that it's the second derivative graph where W double prime of T is at 0 and the points are given there. And this is going to further go on the next 2 slides. We also wanted to see the difference between W and W double prime of T of the placenta weight growth. So we also had to take the second derivative. We also had to take the antiderivative of the original function of the polynomial degree of 4 of the placenta, which was the fitted equation. So the rate of weight growth of the placenta with the actual function graphed on the left, you see it's concave down, then concave up, then concave down, and then concave up. So basically what I said before, when it shifts, when it goes decreasing, increasing, it's presented on the right where those concave down, concave ups are, because at W double prime of T equaling to 0, where the X is where the line crosses the horizontal line of the x-axis is presented there.
After graphing the second derivative, we can find out more about the rate of weight growth of the fetus and where this changes. Our inflection points, shown on the right, represent where the slope of the tangent line is 0 and goes through the x-axis. We can see that before this inflection point, the rate of weight growth is increasing at an increasing rate. At the second inflection point, the rate of weight growth shifts to an increasing at a decreasing rate. And at the third inflection point, the weight begins to increase at an increasing rate after the baby is born. The physiological interpretation of the rate of weight growth of the placenta is very similar to that of the fetus. As shown on the right at the inflection points, after 33 days, the placenta is estimated to increase at an increasing rate until the 125th day, where the rate of weight growth begins to increase at a decreasing rate. Because of the nature of this graph, a computer believes that the function begins increasing at 341 days. However, at this point, the fetus is already born and the placenta is removed, therefore getting rid of all the data after 40 weeks. Comparing the inflection points for the rate of weight growth of the fetus and placenta, we can see that the rate of the placenta changes prior to the inflection points of the fetal weight. This is because the placenta must grow before and as the fetus grows. Because the rate of weight growth in the placenta began to increase at a decreasing rate, the fetus also began increasing at a decreasing rate as well. This proves how important the placenta is in order for fetal survival. After the placentas increased, the fetus began to mimic its rate of change, which expresses why the inflection points occur after the placental growth. The decrease in rate may have occurred due to multiple reasons. This could be the mother's lack of exercise, the mother's lack of nutrient intake, or other health conditions.
We were given a new set of data. It was the effects of exercise on pregnancy. It was from the week of gestation to the placental volume in milliliters, which is our Y values, and the weeks are our X values. And we had to graph that in the Excel, which was also the polynomial of degree 4. And we also wanted to see this in days, so we converted the weeks into days and we regraphed it, and we also got a new fitted equation at the degree 4. So then we wanted to see, if we plugged in a 0 for the weeks, how the placenta was going to be at, like the volume. So then we found out that it was a negative volume. We're comparing this because we're saying that it's a negative volume when the weeks are plugged in as 0. We're saying that the baby is basically the higher dense, and it's sinking into the placenta with a volume of lower dense. But the baby is basically the higher dense. Converted into days was because the comparison between the placental weight and the placental volume had to happen, and the placental weight was already in days. So the placental weight at W double prime of T with a polynomial degree of 3, while the placental volume at V double prime of T with a polynomial degree of 2 was graphed on the right. The graph represents the inflection points, which is like the W double prime of T and the V double prime of T. And the polynomials are graphed on here. So we want to see a comparison between what do they have the same inflection points. And when you look at it at no days, at W double prime of T equaling to 0 and V double prime of T equaling to 0, that they don't have the same inflection points at all. Also, another reason why the fluid levels were really low and a negative value was because of a medical explanation as oligohydramnios, where there's low amniotic fluid levels, and basically this occurs in the amniotic sac of the placenta, and it'll have like a lower average value, as the picture also explains, and then the placenta wouldn't function right. This also causes like premature birth and complications in the baby, and lower oxygen levels and not getting enough nutrients, as we also indicated.
In this project, we learned how the effect of exercise during pregnancy affects the placental and fetus growth. Exercise allowed the placental volume to increase, which allowed the fetus to have more space to grow. There are so many unanswered questions in regards to the data that we received, which is why we do not trust it. We are not sure how the data was obtained, what really went down to obtain the data, so we are not relying on the data to see if it's accurate or not.